Welcome to this walkthrough in DataRobot. Today I'm going to demonstrate how to quickly build and deploy a predictive model. You'll go end-to-end from raw data in a database to a deployed model using multiple core DataRobot capabilities along the way. You'll move through three key phases: data preparation, the model building process, as well as model insights and applications. The first step in any project is creating a so-called use case. This acts as a central hub for all our project assets, data, experiments, and applications. In Workbench, I've already created our example use case. The focus of this example is predicting 30-day hospital readmissions. Using DataRobot, you're going to identify at-risk patients and reduce readmission rates. To upload data files, locate the Predictive AI box and click Data. Here you have the option to browse existing datasets, upload a file, or add data from a URL. You also can set up or use an existing vector database connection, for example to Snowflake, and select your data from there. All files within a use case are stored in the Data Assets tab. For this project, we're using the 10K diabetes dataset. Inside each dataset, you can explore its feature structure and values. This is a hospital and patient data for a mixture of demographic segments who have entered the hospital through different admission sources and who have been diagnosed with various conditions. The target to predict is the column named readmitted, which is true if the patient needed to return to the hospital after being discharged. You can also see that as soon as the data is loaded, DataRobot has automatically initiated an exploratory data analysis. The platform implemented data science best practices to quickly assess data quality, looking for things like outliers, disguised missing values, excess zeros, and inliers. Here, no critical issues has been identified, but DataRobot gives recommendations of how to proceed with the outliers. So data often needs cleaning and transformation before modeling. From our dataset, we'll click Data Actions and select the Open in Wrangler option. DataRobot's Data Wrangler allows us to build a reproducible sequence of transformations, a so-called recipe, on a sample of our data. Inside the Data Wrangler, click Add Operation to build a wrangling recipe. Each new operation updates the live sample to reflect the transformation. Note that if you wrangle your training dataset, you will want to apply the same operations to your scoring dataset to ensure you have the same columns. The recipe panel lists a variety of possible wrangling options. Perhaps you would like to add a transformation that better represents your business problem or remove a certain value for a specific feature. For example, the age column in our dataset is currently stored as a range. For example, 70 to 80. While DataRobot can handle this, we can improve the model's performance by converting it into a meaningful numeric feature. Click on Add Operation and Compute New Feature to create a new feature from the existing features in our dataset using functions and subqueries from Spark SQL, a module for structured data processing. Name your new feature, convert age range to integer, and use this simple function. The expression extracts the lower bound of the age range and converts it in an integer. Once satisfied with our wrangling and engineering, we click Add to Recipe. When we finished adding operations, we can assess the live sample to verify that the applied operations are ready for publishing. Click Recipe Actions and Publish to configure the final publishing settings for the output dataset. Give the new output dataset a name, such as Readmissions Wrangled. Then click Publish to apply the recipe to the source, creating a new output dataset. This will be registered in the data registry and added to our use case. The transformed published dataset has been added to the Use Cases Data Assets tab. We can click on the dataset to see the final feature set, including the new wrangled feature, and explore feature insights. If the dataset needs further modification, you can choose to keep wrangling. Otherwise, from the new output dataset, click Start Modeling to set up a new experiment. This is the experiment setup screen. First, use the Learning Type dropdown to select the type of experiment you want to run. In our case, DataRobot has automatically detected that this is a supervised learning problem. We must now specify the column in the dataset for which we would like to make predictions. In our case, this is the readmitted column as a binary flag indicating if a patient was readmitted within 30 days. Following this, check out the target features distribution in a histogram. After looking at the data and the distribution of our target, DataRobot selects a recommended optimization metric for us, in this case the log loss. But you also have the chance to select between a couple of other different optimization metrics if you prefer. Additionally, we can select our training feature list. For this example, we're going to use the automatically generated informative feature list, which includes features that have been determined useful for building a generalized model. This means that low information features have been removed, as well as duplicates and IDs, for example. This list of selected features will then be used in the modeling process. Before we continue to the additional settings, select your modeling mode. Because the more experimentation we do, the more time and computation resources it will cost. You can therefore select between 3 different modeling modes, such as manual, quick autopilot, and comprehensive autopilot. We're going to use the quick autopilot because it only builds blueprints with a relatively short training time to support a quicker modeling experimentation. You also have the option to make more changes in the Additional Settings tab. Before launching, we can review the default settings. DataRobot handles data partitioning and validation automatically. Here we're using the stratified sampling approach for our cross-validation to balance the proportionality of our binary target values in each partition. In this case, the default setup is like a 5-fold cross-validation with a 20% holdout set. But you could also change this into a train, validation, and holdout split. Finally, we can check the experiment summary information in the right panel, as the metadata cannot be changed once we start modeling. If everything looks correct, click the Start Modeling tab to launch the model training process. The automation is now in control. DataRobot will apply your partitioning settings, pre-process the numeric, categorical, and text data separately, select the machine learning algorithms that are suitable for your problem and data types, and then start testing them one by one. It is as if you've handed your experiment to a team of top-tier data scientists, and you will come back later to review all their work and results. No further input is needed from you at this point. If you close the browser or exit the application, the work will continue. The time it takes for the experiment to complete depends on the amount of starting data and the number of concurrent jobs that your count allows. I've now skipped ahead to show you how the final model training is going to look like. So there's one more model that is being trained in the job queue. Here you can see the leaderboard, where we track the performance of each model the autopilot builds. They are sorted by performance on the specific metric we selected and the specific partition. The model at the top is the one that is performed best against our unseen validation data. You can now select any model and mark it with a star for easy reference. Now that the model building process has finished, click on the top performing model to familiarize yourself with the insights available for model evaluation. Each model's landing page provides an overview that displays available insights for the model. If we navigate to its Details tab, we can start by expanding the blueprint. It represents the concept of the modeling pipeline and is one of DataRobot's core strengths. The blueprint setup process is dynamic and specific to the data you fed in. If you set up a different problem tomorrow, the resulting blueprint would be different. We're leveraging a huge library of methodologies, from open source like Python and TensorFlow to proprietary ones. This blueprint shows every single step that went into building that model, from data handling to the model algorithms, ensuring full transparency and governance for our entire modeling process. Each box is accessible, and you can even click on the DataRobot model document for more detail on the process. Close the blueprint view and open the feature impact in the Explanations tab. This insight tells us which of our input features are driving the model's predictions the most. We can see that the number of total inpatient visits in the past, as well as the number of diagnoses and the medical specialty in the hospital, are highly impactful. Notice how our engineered feature, the convert age range to integer, is also highly ranked, and therefore validating our earlier data wrangling work. After looking at the feature impact onto the model's predictions, we might also be interested in the different feature effects. So by viewing the effect of a feature, let's say the number of inpatient procedures, we can see that if the count of the feature increases, the probability of readmission also increases, and this gives us a clinical reason behind the model's prediction. We might also be interested in looking at a specific prediction explanation. This is the most granular level, a row-by-row or prediction-by-prediction view. In this example, where we predicted a 90.8% chance of readmission, the 5 inpatient procedures had the greatest impact on this prediction. Clicking on the prediction reveals the features influencing it, all ordered by the specific importance. In some models, especially those involving text, you will see the option to look at the word cloud. Since we have text in our data, we can use this model to understand how specific words are related to our target. The size of the text indicates the frequency in which it appears. The color indicates the relationship to the target. Blue means that it pushes the probability of the readmission down, while pink means that it pushes it up. Last but not least, we need to evaluate the model's performance and not just blindly trust the scores. For this, we have several different tools. Inside the ROC curve tab, we can find, for example, the probability distribution curve. This distribution curve illustrates the distribution of actual values in relation to the display threshold. So every prediction on the left of this dividing line is classified as false, and every prediction on the right of this dividing line is classified as true. Here, the ROC curve is super helpful for binary classification. It plots the true positive rate against the false positive rate for a given data score. This helps us to find the optimal threshold to separate readmissions from non-readmissions. We also have the option to look at the confusion matrix to identify how many true and false positives, for example, we have for a given threshold. In the lift chart, we are depicting how well the model segments the target population and how capable it is of predicting the target. So it bins the data and then displays the actual versus the predicted values. And last but not least, we also have the option to look at the different metric scores that I've mentioned previously. So not just for the selected log loss optimization metric, but also for any other metric that is available inside DataRobot. Now that the model building is complete, we can access a variety of next steps for our model and the model actions. For example, we have the option to create no-code applications. DataRobot allows users to interact with the model directly without writing code. We can select a pre-built no-code AI template to build applications that enable core DataRobot services and are shareable with other users, whether or not they have a DataRobot license. This lets a user input patient details and instantly see the model's predictions, enabling frontline staff to assess risk in real time at the point of care. Finally, for our model to be useful, it must be deployed. From the Model Actions menu, we can register a model and then create a deployment. For example, we can set the registered model name, the registered version name, and the specific prediction threshold. And then we're going to register the model. Deployment inside DataRobot is fast and enables key governance features, monitoring data drift, checking model health, and ensuring service reliability, all of which are critical for a regulated environment like healthcare. As we can see, we are currently creating a model version 1, which is registered, and soon we are able to deploy. Now that the registered model has been built, we see this Ready for Deployment tag and are able to click Deploy. DataRobot now provides the option to select a serverless prediction environment on the platform. If you have the appropriate credentials, feel free to set up any of the other environments in the list instead. One more time, we have the option to look at the different modeling information, like the model, the prediction type, the threshold, and the target we've selected. And with that, we're able to deploy our model. Now that the creation of the deployment has finished, we're able to find our deployed model inside the console in the Deployments tab. Here you can find an overview of all the different information related to the deployed model. We now have the option to also monitor the model and make predictions. Here, DataRobot offers several methods for getting predictions on new data from a model, also known as scoring. For quick manual predictions, you can simply drag and drop a file into the Make Predictions tab. You can also make real-time predictions by sending an HTTP request for a model via a synchronous call. After DataRobot receives the request, it immediately returns a response containing the prediction results. Because the model is already deployed, you can navigate to the Prediction API tab to access and configure scripting code that allows you to make simple requests to score data. Last but not least, you can also make prediction in batches, for example, to score large datasets in batches with one asynchronous prediction job. For this, create a job definition to save and schedule batch prediction jobs. This brings me to the end of this walkthrough. We started with a raw hospital dataset, used a data wrangler to engineer a powerful feature, launched Autopilot to automatically find the best model, and then explored the model's insights before preparing it for a no-code application and seamless deployment. Thank you for listening.